back.
Hi. Hello.
Like, I beat you to it just by a
I
little. All right, welcome back to the first day of second semester, and we're kicking off with a brand new unit. We're going to be talking about exponential functions. But before we jump headlong into that craziness, let's talk about some remembering. So I asked you to work on this, remember this before the recording, and I think a lot of you took this 12 squared and you wrote 144. How did you get 144?
Because 12 times 12 is 144, I think.
Because 12 times 12 is exactly 144. Perfect. Let's flip over to this fraction really quick. What would I do here?
You would solve it.
Into a decimal.
Let's avoid changing to the decimal just because in a couple units, which are going to come by really, really fast.
And do you get rid of the parentheses?
Don't you just times it?
Don't you square root?
Yeah, you're just going to times it by itself.
Oh.
Okay?
Right.
So we're going to do exactly what was done here, which was multiply that thing to itself 2 times, but the thing this time is a fraction. So I'm going to write the fraction times a fraction. I want you to avoid putting it as a decimal, please, because in the next couple units, we're going to be doing like everything is fractions with a bunch of crazy letters. And Anani's going, yes, I remember seeing that, and it freaked me out, right? Yes? Okay. Don't worry, I'll make it super easy for you. How do you multiply fractions?
You multiply.
Top.
You
Across, the top times the top, the bottom times the bottom. And just,
4/10,
yep, just that. So 2 times 2 is,
4.
and 5 times 5 is,
Oh, 25.
and you're done.
Oh, never mind.
I said 10, I don't know why.
It's okay.
So do you like?
If we put in the calculator, we're gonna get that too.
I don't know if it's
Maybe.
No, because I got
Sometimes kind of
0.6.
Okay, so the answer is if you stick this into a calculator, you are probably not going to get this. You are likely going to get some sort of weird, crazy decimal. So I need you to do this by hand, write it out to this, and then if you need the calculator to help you with the multiplication of those bigger numbers, you can do that. But leave your answers as fractions.
So
Okay?
we're always gonna times it across like.
Straight across, always.
do we ever like make the numbers smaller?
Oh, beautiful. So you're asking, are we going to reduce the
simplify
final
it.
fraction, simplify it? The short answer is yes, you have to make sure your answer is simplified, but simplifying these numbers
I
is,
didn't like that.
I do, look, just all the questions. I do need it in simplified answer. I don't want it as decimal. Decimal isn't necessarily simplified. Okay.
So you always have to simplify.
You always have to simplify if you can. Ladies, thank you. You always have to simplify if you can. And knowing whether you can simplify at this stage at the very end is really hard because these numbers are going to get really big really fast and what? I don't know. So for this stage, if you simplify here and make sure that little fraction inside of there is in simplest terms, then the answer will be in simplest terms. Okay? Okay. I want to look at this one with the negative. So, same thing. It says take that thing, everything in the parentheses, and multiply it to itself. Right?
It would come out positive, right?
It comes out positive.
9.
But if I slide my paper over to this one, notice how the negative is not in parentheses. By order of operations, this means that I have to do that part of it first. I have to do 4 times 4 before I can apply the negative to the very end.
So it would be negative 60.
Okay? And so that's something that you're going to have to like kind of really keep track of and be really careful.
How come they're not both negative?
Because there's no parentheses. See in here, there was
so when there's
parentheses.
parentheses, then they're both negative.
Then they're both negative. If there's not parentheses, then you apply the exponent and then you stick the negative on afterwards.
Where it says the negative 4 with the parentheses and the 3, when I had put it in the calculator, it gave me negative 64.
Mm-hmm.
But on top of that one, it was a positive.
You're absolutely right. So she's noticing that these two look the same, but here your answer is positive and here your answer comes out negative. Here's the reason. We're multiplying it to itself 3 times. So we have negative 4 times negative 4 times negative 4. And so while the first two multiply together to give us a positive, that multiplication of that third negative number turns it back into a negative. Great insight, though. Thank you. All right. So now that we've remembered this, let's look at exponential functions, and this is what they look like. It's some number raised to a power, but unlike all the other functions where we had the variable down in the bottom, we now have the variable up in the exponent, which means I'm going to give you a number like 2. And then you're going to raise it to a bunch of different powers, and you're going to take all of those answers and you're going to plot those to figure out what the graph looks like. That's what an exponential function does. Okay? So in this form, the number that is sitting in the position where the letter B is right now, it's called the base. All about that base, about that base. It's the number that the exponent is acting on. Which means it's the number that's getting multiplied over and over and over again by itself. And it does that however many number of times we're told to once we know what the value of x is. Now we have two options for the base. The base can be bigger than 1, or the base can be smaller than 1. If it's bigger than 1, we're going to call this function, we're going to classify it as a growth. And if it's smaller than 1, but still positive, so some sort of fraction, it's called a decay. Okay?
So what is it? Decay?
A decay, yes. Now, these words get used a lot in the sciences, especially in biology, when we're talking, I don't know, the population of people that have gotten sick. So the CDC, the Center for Disease Control, that put out the alert, oh my God, there's a bird flu that's coming in, and there's mad cow disease, so don't eat raw meat and stuff like that, right? You've heard those announcements that have come out? And it's a little scary and concerning. Well, what they're doing is they're modeling how these diseases can affect populations, and they're using these growth or decays. Okay? Let's do an example, and then we'll play with our Desmos app, and we'll look at what each of these functions look like. So give me a number that's bigger than 1.
2,000.
2,000, and what was your number?
2.
2002 was a good year for me. I'm trying to remember what I did in
Hey, the year I was
2002.
born.
See? Good year.
I was 1.
You were 1. I feel so old.
You were born 2000.
I was born 2001.
I had my first wedding anniversary that year. There we go. That was the something good.
Did you say I'm old?
Wait, wait.
All right. So come to your Desmos app. There it is. Desmos. Hashtag this video is not sponsored. And I'm going to put in 2002. And then to get the exponent, do you see the little button that's right here that says a to the b? You're going to click that. And now suddenly you're in the exponent. And then I'm going to click the x. Okay, because my calculator has trouble showing this, what I'm going to do is I'm going to get rid of the 2000, okay? And I'm going to put 2.
Oh.
Just to make it a little fatter, because the 2000 makes it like really skinny.
Wait, miss, can you go back to how did you get the little exponent?
The little exponent, I pushed this button right here.
Wait, miss, you zoomed in,
The
right?
B?
The A to the B.
Okay.
Yeah.
I did.
I didn't zoom in yet.
Oh, what the heck?
Okay?
Because mine is showing 5s.
And then X, right?
Yep, and then X. But make sure that that X you used with the A to the B first. So delete the X if you haven't. So you've got 2. And then you push the A to the B, and then you push X. So it's going to look like this. So there's my 2. And then I'm going to push the A to the B button. And see how like the 2 jump down?
Yeah.
And then I'm going to push the X. Because
Okay,
otherwise it looks like that.
Stop.
And I don't want that.
Why is it green?
I want that.
Why is
Okay.
it red?
All right, we all have this thing.
Yeah.
That's an exponential growth. You notice that as we are moving along in the X direction, this thing is getting like really crazy big in the Y. Do you notice?
Oh, okay.
Whoa.
Yeah, right? Well, like if I zoom out, like look at this.
Miss, I think I messed up.
Right? It's crazy. But, okay, but here's the thing. Is it ever going to stop moving along in the x direction? No, it's just going to take a long time for us to get over here to x equals 100.
This
Like
is-
we have to be way over there before we can get to x to 100. But we'll get there eventually, right? It's just going to take a while.
Okay, I gotta zoom back in.
What about in the negative direction? Are we going to hit all the x's in the negative direction?
No. Yes.
Yes, because it's only one.
Yeah, because look, it's there. It's just like, it's kind of hard to see because it looks like it's on top of the axis, but it's there. So our domain is all of the real numbers on the x. All of them. Let's try to figure out the range. Remember that the range is all the values of y. So we're looking at this way on our graph, where the graph appears in the up or down y direction. It's very easy to see that in the positives, it's going to continue on for forever, right? And it's going to get to infinity like really fast. But if we look here in the negative x direction, it looks like it hits 0, doesn't it? Well, if I zoom out just as far as I can,
How far does it go?
It goes
I
like
don't
2 times
look,
10 to something.
I'm at 500,000 x right now. There's a million x.
You keep
There's
going
2
and-
million x. Okay,
so
and now
times
we're in
10.
scientific notation, and I don't really know what numbers these are anymore.
That's
But
right.
look, it's still going.
Miss, that's trippy. You can stop.
But here's the thing. Does the y ever become negative?
No.
No. It looks like it turns into 0. So the question is, where does that happen? Okay, so I'm going to zoom back in.
I did that right now, but I had to
Miss,
do
you have to
another
press the
blank.
button. There we go.
Thank you.
Oh, what?
I was like, how do you, this is going to take forever. And then you said push the hole, and I was like,
I created a new blank, right?
well, duh. That makes sense. Okay, so I'm going to zoom in. Okay, look. It looks like it hits the 0 right about here. It's not at 0. But it's not at 0. Okay, so I'm going to keep going. Okay, there, look. It finally hit the 0 here at about now.
Miss, why did you even all the
Miss,
way
I'm at
and
like
go
13.15. It's already
as
touched
much as you can?
the 0.
Oh, Miss, it didn't even hit
You're like a tree.
I'm lost now. I can't. I just.
It never touches a 0.
It never hits the 0. If it looks like it's getting closer and closer, we're not sure where it becomes 0, but we're sure that this thing's never going to become negative, then there's no way it can ever be 0. So our range has to stay bigger than 0. Let's look at the decay. Remember, the decay happens when the base is somewhere between 0 and 1, so some sort of positive small fraction. So can I please have a reasonable 10
I was gonna say
in the
1,000.
denominator?
What, Antonio?
Oh.
Don't you know?
So 1 over 10 is our decay. So we're going to come back to our Desmos app, and we're going to do 1 divided by 10.
1 divided by 10.
And then you're going to push the sideways right arrow button. Is that, can you see it? Okay.
And
Um,
then put A, B.
So that way here, and then a b, and then the x. And that way, the calculator knows that
I got rid of the line.
I want the
That is so
entire
cool.
thing.
And then the AB.
And then make sure that you push the little right arrow here, right here, this right arrow, so that way it,
Like it's out of the fraction.
yeah, it gets out of the fraction. Otherwise, it tries to do it inside the fraction, and that doesn't work.
Miss, did you press the division symbol? Or?
I did 1 divided by 10.
Oh, okay.
All right. So there it is. It looks
Like a graph
exactly like the other one, except it looks like there was a reflection on it, right?
across the X, Y.
Oh, like across the y-axis. We're not going to call this a reflection yet. Okay? We're going to call it a decay. All right, but the domain looks like it's the same as the other one, doesn't it? And the range?
Same, probably.
The same. Yeah, it looks like it's the same. So we're going to go ahead and just call it the same.
I mean, we could check though.
We could.
It'll take years.
Question. Can B equal 1?
What's B?
The base. All about that base, about that base. To a power. I'm gonna figure out that song soon.
Liz, you have your songwriter right here.
I do. Songwriter, get on that. Need new lyrics.
Okay.
Can B equal 1? What do you think? What happens if B is 1?
It stays the same.
Okay.
This year.
What do you mean by that? What do you mean by that? Stays the same. If B is 1, what happens? We have 1 to the 1 power, 1 to the 2 power, 1 to the 3 power, 1 to the 4, 1 to the... Because we're changing the exponent, right?
Oh, it is.
Oh, yeah. Miss, the recording's on.
So, I mean, this isn't to say that B can't be 1, but it's boring. And it doesn't really tell us much. Especially if we're trying to use this to say something about, I don't know, the population of bacteria or something. Yeah, I don't know. Look, this is me trying to be scientific.
Scientific.
Stay with me. Here's what we have it look like. Notice we have this letter A in front that I haven't talked about yet.
Yeah.
So I have some number A times this base being raised to a power. Okay? So I have, here's my base being raised to a power. Whoops. I don't even. There we. Ah!
Wait.
What are you trying to
Miss,
do?
I'm gonna try that.
That. I was trying to do that. I was trying to make the parentheses look pretty and I got confused.
Oh, wait.
So the exponent is on the inside?
The exponent's on the inside of the parentheses.
There.
And now we're going to figure out what happens when we have the number in A. Because right now we have it as a 1, right? Because there isn't anything there, so you assume it's a 1. All right, so give me a non-1 number.
Oh,
3.
3.
a not one.
It
number.
moved. It moved.
Ooh.
What the what? I'm going to turn that off just so that this brightens up a little bit. Where did it move to?
It moved
2, 3.
It moved to 3. Okay, give me another number.
5.
5. It moved to 5.
13.
13.
Wait, so the number you put in front of it, that's like the weight.
What about 2 million? No, just kidding.
So this number A becomes the y-intercept. And that makes this the starting value. Okay, but I'm gonna write something that's probably not gonna make sense for a second, then we'll explain. It's the starting value when time begins. I don't mean this in the metaphysical, spiritual, like the universe was created start of time.
Big bang.
That's what
Big
I
Bang.
was thinking.
Right? Me too. That's not what I mean by this. What I mean by this is if I'm using exponential growth or decay to model something in the real world, time starts when I start my stopwatch to time my experiment. Or I start counting that things are going on. This growth or decay thing gets used a lot in one of my favorite games,
Ah.
Plague
Plague
Inc.
Incorporated.
If you've never heard of this game, what Plague Inc. is it's a video game where you are playing as, hashtag this is not sponsored.
You have to try to kill the whole population of the world.
Yeah, you are basically playing as a disease, as an infectious disease,
That's what I like to call my sister.
right?
Same.
Same. So you're playing as like a bacteria or a virus or a fungus or a parasite or any of these, this
Play a demo.
play demo in a bit.
Have you done the
Um,
vampire one?
I have not yet. Haven't unlocked that one. So he's like, I can tell you played this game before. So you are playing as one of these disease types, and yes, there's scenarios on here for like the Black Plague, which was the bubonic plague in Europe. So it's got some history to it. There's the AIDS, There's, the different types of flus. There's Ebola and E.
Everybody
coli
in
and all
that
those.
world died of AIDS.
Well, you can. And your goal is you are playing as that virus, as the HIV virus, and you're trying to infect and eventually kill
Wait, but
the
why would
entire
you
world's
roll into it?
population.
Yes.
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 That's what this game is. Okay? This is an Android phone, by the way, so I don't know if it's available on Apple. I'm so sorry. I paid $3 for mine but I use it to unlock everything.
Install.
Okay, so basically, here's what's happening. Okay? So I'm gonna start a game.
All right. Wait, are we done with the notes?
Okay, we're not quite. Wait. Shh. We're not quite done with notes. So I need to tell the game where the plague is starting.
North America.
Okay? So we're going to start here. As soon as I hit the play button, time starts. That is, time is 0. And so the very first person who gets sick, which the Center for Disease Control calls patient 0, they're my A. They're my starting value. So if I start with 1 person sick, A is 1. If I start with 10 people sick, A is 10. Okay? And now 1 person has been infected. And you can see that time up here on the upper right is ticking away. And of course, I'm infecting more people, but those are airplanes and things. Yeah, well, I'm not going to actually play the game, but now in about a year, we've infected 11 people without having done anything. Yeah, it is really slow, and it's because my disease isn't particularly infectious. Like the common cold, I could sneeze, and like everyone in the room gets sick. He's like, just play the game. We want to see gameplay. So it's the starting value. That's what we mean by time begins. You start the game. Okay, so the next question for you is, I've got this little box up here that says A should not be 0. Why not?
Because
Then it wouldn't go.
I don't know.
What do you mean by it wouldn't go anywhere?
Because
Because like
It
you were
doesn't
just saying,
change
if you
anything.
start with
Zero.
0 people infected, how are you going to get more infected?
Because time is 0, you're right, but then as you move forward, what happens? You said it doesn't change a new thing.
Yeah, because didn't you isn't that where you were using the 13 and the 10? Yes, that's where I was using the 10 and the 13 and the 9 and the 5, and you saw it jumping and moving. But now this is 0, and so as he was saying, because you're multiplying by 0,
It wouldn't move.
it doesn't move, it always stays 0.
Hey,
Shall we look at it?
yeah.
Okay, so let me pull up my Desmos
The
app
game
again.
or the
No, Desmos app. We're done playing Plague Inc. for now. I'll kill the world another time.
All right.
Hashtag come back after school.
Video game club.
Yeah, video game club. I'll stream it. Did it not work? Watch me kill the world. That's what we'll do after school. There it is. It's a super exciting graph, guys.
Is that a 0?
It's a 0.
Are you sure?
What's that line?
Okay, so let me try to change the color. Can I change the color?
No, I think.
I don't know how to change the color. I think it does. So let me just put in another one. There, now it's red. Now you can sort of see it.
So it doesn't move from there.
It's a 0 slope. It's a 0 thing. Nothing's happening. Because as Jeff had said when he equated it to the game, no one's sick. So if no one's sick, you're not going to get anyone else sick. And so the disease literally does nothing when your starting values are.
So you mean the disease is 0 or nothing?
Yeah, it's this is 0.
Non-existent.
This is 0. All right, in your own words, you have 30 seconds. I want you to explain to yourself why A should not be 0 for these exponential functions.
No, we use the game as an.
Anything you want, your own words.
I was gonna think of. I thought of something, but it just. No.
Go back to the game.
Can I put that 0
Oh,
multiplied by nothing?
Perfect, do it. In your own words. Without talking. You are writing for yourself why A should not be 0.
right, we've got some functions here. Let's classify them growth or decay. G of x. Growth or decay? How do you know? Because this number is bigger than 1. This one, growth or decay? Good. Why?
Because it's smaller than
Parentheses.
zero.
Because this number here is smaller than 1. What is the name of the number in this position?
Denominator.
B. No, wait, no.
B, which is the
Base.
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 Oh,
Growth.
All right. This third one, growth or decay? And this one? Beautiful. You guys are masters at this.
How?
Let's practice. All right, looking at g of 5, I'm going to take the g of x function, which says 2 to the x power, but instead of writing the x, I'm going to write a 5 because that's what I was told. This means 2 times 2 times 2 times 2 times 2.
4.
Equals.
Uh-huh. 2 times 2 is 4. 4
4
times 2 is
8.
times 2 is
16.
16 times 2 is
32.
It's 32.
All right.
if you need to use a 4-function calculator, the one on your phone, to help you out with some of these multiplications because the numbers are getting too big, go for it. Just make sure, like when you get to h of x.
Excuse me,
Yes?
Anayichi is going home.
Thank you.
Thank you.
This means, okay, so now you're going to need to catch it on YouTube. The numbers are getting big, so you can use your calculator to help you with the multiplications. Okay, so let's talk about this one. This one means take this function, take this fraction, and raise it to the third power. That means take the fraction and multiply it to itself 3 times. Okay? Multiplying all of the tops together. Okay,
It's too
I want you to watch how I'm writing this, okay? 2 times 2 times 2 I can think of as 2 to the third power.
Did you not hear her?
Yes? Yes? And then 3 times 3 times 3 I can think of as 3 to the third power. Okay?
True.
So 2 to the third is 8. 3 to the third is 27. I'm writing this intermediate step because I'm sure that by now doing this is getting annoying. And you would like a shortcut, especially for the fraction. Here's your shortcut. Here we go. Come to here for me. Here's your shortcut.
I tried
So
to do
this-
that one and I got 1. I don't know. I got a weird number.
That's okay. That's all right. All right. So there's what the function says. Here's your shortcut. Your shortcut says write the fraction again, but on the numerator, put the power, and on the denominator, put the power.
And then just
Distribute the power throughout the entire fraction. And then just do the multiplications as you're shown. 1 cubed is 1. 6 cubed is a number I don't know. Someone with a calculator helps. 36 times 6.
36 times.
216.
Oh, never mind. That's what I got. I just did the long way.
Okay, no problem.
I just got I found it weird.
That's okay. You got to the same answer. You're good. Sounds okay?
Yes.
All right, I do come to your homework because there's a couple of items I want to do with you on your homework.
the back.
Yeah. Let's look at this one, number 24, which deals with I of x. All right. This says take the function for I,
Oh, this
all
is-
of that, and wherever you see an x, replace it with that 2. So that's what I'm going to do. I'm going to rewrite the entire I function, except anywhere I see an x, I'm going to replace it with the number 2. Okay? Order of operations says I have to handle exponents, the parentheses, then exponents, then multiplication, division, then addition, subtraction. So I'm looking inside the parentheses, and then I see the exponent. I've got to clear the exponent first.
Okay.
Wait, so I had to put it in parentheses.
So I've got to clear that 3. So I'm going to have -2 here. I'm going to rewrite that exponent. And everything else stays the same. Okay. Now I need to go ahead and do what the exponent is asking me to do. 3 to the third. 3 to the third is?
Isn't it squared?
It's 9.
27. It's not squared because I have 2 plus 1.
Oh, okay.
All right, and now I can do 2 times 27.
Yeah, I messed up.
-2 times 27.
Yeah,
-54. And then I can do -54 minus 10. I don't believe you that it's -44. 64, I believe you.
Oh, yeah.
All right? Looks okay?
Yeah.
Okay.
Miss, so when you replace the 2, no,
The X with the number.
you had to put parentheses above it?
I didn't. I could if I wanted to. And if it were negative, I might want to.
Is it best to not put it or to put it in there?
If you're not sure, you can put it if it helps you.
Miss, can I ask you?
Yes.